Dun 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 dun. Flaps! Ah! Saviour of the universe! Yeah. Well, that went well. It's weird when there's nobody interacting with you. You know what I mean? Okay, so we're going to look at Unit 66. We're going to look at flaps and lift augmentation devices. So straight away, we're going to look at your plain flap. There's loads of different types of flaps. If you check the PowerPoint, you'll see that there's lots of different types of flaps out there, lots of different designs and how they evolved over time. So the first one that came out with, pretty similar to your standard control surface. I'll just draw that for you. So you've got your airfoil there, and then you've got your plain flap, which just extends downwards. Okay, only go the first flaps we're going to talk about, they only go down over. Yeah, and all they're going to do is exactly the same as your control surface. They're going to increase the Bernoulli effect over the top of the wing. Yeah, or I call it the Bernoulli effect. It's Bernoulli's theorem, but it's actually, you know, it's just, we'll just call it a lift. Okay, they'll increase the camber over the top of the wing. You're also going to have a bit of Isaac Newton on the bottom. So it's going to deflect off there. Every action is equal to an opposite reaction. And because of this bit at the bottom, because if you look at the cross-sectional area of there, that's how much wing was sticking into the airflow before. And now what we've got is we've got all the way down to here. Yeah. So you've increased the how much, if that's the relative airflow there, you've increased how much surface area is in the relative airflow. So what force have you increased? You've increased drag. Okay. So we've got more lift going on. Yeah, so we've got more lift, but we've also got more drag, and we've got more form drag there. Instead of P. So you've got more drag there. Now, as well as that, what you're going to have is, right, because you've increased the lift, you've increased a bit of, I'll just use this symbol here for kind of induced drag, so you've increased the induced drag a little bit, and as well as that, the air here, when it pushes down into the airflow, you have different settings. Now if you watch the video I made using the War Thunder game on the Lancaster, right, that talks about split flaps, and you'll see how flaps, how they're actually used. Okay, so let's look at how they're used. I'll just get my board over there. So that's a plain flap, and that's plain as in ordinary plain flap. Right, now what they do is so your flap comes down. On takeoff, you'll put your flap about halfway down like that. Yeah, and that will give you a little bit more lift. And then for landing, what you'll do, right, you'll extend the flap all the way down for landing. Now, the reason you do it, there's two different settings. There's like 3 or 4 different settings. You know, well, there's any setting you want if you have adjustable flaps. On takeoff, you want a little bit more lift, but you don't want as much drag. Okay, and then on landing, you want quite a lot of lift, and you want as much drag as you can get away with. Okay, before the aircraft stalls. Now, remember when we talked about airfoil profiles in topic, I think it was topic 1 or topic 2, we said a big curvy airfoil like that would be like a high lift airfoil. Yeah, and that's what you're essentially doing with a standard airfoil. You turn it into a curvy airfoil. Yeah, to increase the lift. So that's the basic principles of flaps. That's how they work. That's all you need to know about them, really. The mechanical operation, you have, well, we'll talk about that one. We'll talk about different types of flaps, but that one's basically would be a hinge. So there's your airfoil, and what you'd have is you'd have the flap like that, and you might have a hydraulic actuator that is a linkage into the, you know, and it pushes down using hydraulics, and when that retracts, it's going to pull the flap down like that. So why do we have to use hydraulics for flaps? Because you've got a lot of air pushing on that control surface. Okay, now flaps are known as secondary control surfaces. So your primary control surfaces are your ailerons, your elevators, and your rudder. Your flap is one of the first one we're going to look at. Is your secondary flying control surface. Right, so that's standard flaps. We'll stop that video there, and then I'll put another video on of different types of flaps, and we'll look at that. Okay, these videos are quite short because my camera keeps shutting down on us. Okay, so I apologise I can't put it all in one video. I'm working on that. I'm working on different cameras and things. Okay, so goodbye for now, and when next see you again on Unit 66, we'll be looking at different types of flaps and advantages and disadvantages of each type. And I will try and talk less quickly, because I realise when I talk to a camera I'm going 400 miles an hour. Yeah, so I'll try and talk a little bit more slowly. Yeah. See you later.